Cool. Starting. Ready, Savannah? Yeah? Okay. So the way I would start with the classification of these bad boys is by thinking about how many products there are and how many reactants there are. That, to me, is the easiest way to kind of see groups. Right now, I see 2 reactants and 1 product. This one is 2 reactants, 1 product. So I'm going to put you guys together. I see 2 and 2. So I'm putting this guy over here. 2 and 2. Putting that guy over there. 1 and 2. So did I have one? No, I have a 2 and a 1. 1 and 2. 1 and 2. This one's 2 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 and 1. So far I have 3 groups now. Are we okay with that so far? All right. Let's talk about some of the things that we are seeing in these groups. And then we'll talk about them in the group. Okay. So these 3 that I've grouped together, and these 3 that I've grouped together, these 2 I've grouped together for some certain characteristics that I'm looking at. So the top 3 all have 2 things becoming 1. Last year we talked about that, and that is which type of reaction? Exchange. No. Combination. We are combining things together, team. So you see how we have sodium and chlorine coming together to make 1 product, sodium chloride. We have calcium oxide and water coming together to make 1 product, calcium hydroxide. We have magnesium and oxygen coming together, making magnesium oxide. These are examples of combination reactions. Feel free to glue these into your book so you know that this is a group. So that is our first type of reaction that we've talked about last year. Moving on. Wait, gotta find your 3 and put them together. You can glue them in later. Do you want me to go back? So calcium oxide and water making calcium hydroxide. That is a combination reaction. You are going from multiple products to multiple reactants to 1 product. I'll say that again. Multiple reactants to 1 product. That's a combination reaction. Do you need me to say it one more time? Okay.
Well, can we just say calcium monoxide was combination?
This one? This one is a combination. Yeah. So all these 3 up here are all combination reactions. These 2 down here are a different reaction. These 2, you have 1 thing becoming multiple products. So this one is decomposition. It is breaking apart, decomposing. Think about dead bodies. Decomposing. Dark, miss, dark. So do you see how we have 1 thing? Sodium carbonate becoming 2 things. Sodium oxide and carbon dioxide. This one here, calcium carbonate, breaking apart to become calcium oxide and carbon dioxide. You have 1 reactant becoming multiple products. Decomposition. Yeah, so this one up here, combination, multiple things becoming 1 product. This one here, 1 reactant becoming multiple products. Do you want me to write any of this down?
Nope.
We got some nope and we got some yup, so I'm going to go with the yup. People are like, I don't remember this from last year, miss, because you were my teacher. That was a good question. I have not unpacked my boxes, so I don't know where it would be.
Oh, it smells nice.
Yeah, I lit a candle because you guys were complaining about the stink. There you go. All right, so combination. We have 2 plus reactants, and that becomes 1 product. That is our combination reaction, as a little shorthand to remember it. Decomposition. Think about decomposing bodies and things breaking down. You have 1 reactant becoming 2 or plus products. Decomposition. It decomposes, breaks apart. All right, can I keep going? Yep. Yes? No? Yes? Okay. All right. Now this one's a bit more challenging. So let's see what we notice pattern-wise. So what we could look at to help us figure out what's going on is we could look at the states. So we see how these two are aqueous. It has one aqueous product and one solid product. This one's solid plus an aqueous. We have an aqueous and a solid. So are these two similar, or do you think they're kind of different? They're kind of different. This one, we have two aqueuses, a solid, and then an aqueous. Does this one match this one or this one? Left or right? That one, left. This one here, aqueous, aqueous, solid, aqueous. This side. This one here, solid, aqueous, aqueous, gas. It's more similar to this one. All right. These reactions up here, these are your displacement reactions. Hopefully this is ringing a bell from last year. Displacement. So you see in this case, let me grab some more markers. We started with zinc, and then there's copper sulfate. And then when we look at the product, my product is zinc sulfate. So now this zinc has replaced this copper, and then the copper has been bumped out. So it's displaced it. Okay. We have zinc, we have copper sulfate. This zinc has replaced the copper in the copper sulfate. So now we have zinc sulfate. So this is where my zinc is now. And then my copper's been bumped out. Displaced. Displacement. That's our displacement reaction. This one over here, I'm just going to try to keep them in so you can both see them. Magnesium and hydrochloric acid. Do you see how this has displaced the hydrogen? And now we have magnesium chloride. Displacement. So when we are talking about displacement, we're talking about a replacement. Do you want me to write it down? Are you okay? All right, next one. Trying to find another color for us. Actually, we're going to need a couple more colors. Just trying to find some more. There we go. Okay, let's talk about these guys. So this one here, you're going to have ionic compounds. Let's go through, and I'm just going to show you guys. So we have that. Oh, I need 4 colors actually. Let's see, blue and blue. Okay. Making a mess. All right, so in my initial combo, I have lead and nitrate. And then in the second combo, I have potassium and iodide. So what I've done is I've put the first color code as the darker blue and green, and the second grouping as lighter blue and green. And I've assigned green to the cations and blue to the anions. Are we okay with that so far? Right, when we check the products, there's my potassium, there's my nitrate, there's my lead, and there is my iodide. So what do we see happening? There's an exchange. So we also call this exchange reactions. So we swapped some stuff around. So in this case, both pairs have been swapped around. So for example, this anion has been swapped with that ion to form 2 new products. Yeah? Okay. Do you guys need me to do the other ones, or do you kind of get the idea without? You get it? All right. Now the other thing, that's fine. I'm happy if you get it. The other thing to note, okay. The other thing to note is that one of these products are solid. Yes? So we call these two things. First thing we can call these guys is exchange reactions because the ions are exchanging. But the better terminology for this reaction, since solids are forming, are precipitation reactions. So we formed a precipitate, aka we formed a solid that will fall out of the solution. It'll form a solid at the bottom when we mix the two together. Hopefully this rings a bell from last year. Or you want me to quickly show you guys a video of it? Show a video? Or you got it? Savannah? You got it? Okay. Moving on? All right, so 4 different reactions that we talked about. The one that's going to be based off of this internal assessment is going to be this last one here. So last year you guys did an internal called selective chemical reactions. It was about all 4 of these different chemical reactions. You wrote equations, you figured out which one it was, you justified how you knew it was that type of reaction. This year we are narrowing down the scope and we are only looking at these reactions here.
So it's easier.
Yes and no. Actually, I would say it's easier.
Nah, it's harder.
Now you think it's harder. I'm just going to tell you it's easier. It doesn't necessarily mean it's going to actually be easier. I just figured if I tell you, you think it is. All right, so that's kind of the first thing that I want to talk about with this internal. I'll drip feed more and more information as the days go by, but the main thing I just want you guys to get across today is that we are focusing on the precipitation reactions over the next couple weeks. Cool? Moving on? All right, I'm just going to pause the video recording. All right, just getting some markers that I haven't used color-wise. Okay. First word is sand, so I'll put that into a starting group on its own, and then we'll create the next group based on whether or not we think things match with sand. So, sand's my first item. All right, the next thing on the list is flour. Do you think flour belongs with sand, or is it starting the next group? It is with sand. Oh gosh, it's already looking bad. All right, salt. Do you think salt belongs in the group with sand and flour, or is it in a new group? That is correct. It is in its new group. All right, oil. Do you think that belongs in the first group or the second group? It's in the first group. It's like it's all very arbitrary. You know that, right? Okay. Last thing, sugar. Is that in the first group or the second group? Any guesses to why these 3 belong together and these 2 belong together? Huh? Salt and sugar are very similar. You're right. They're both kind of like crystally structures.
Solid.
Bingo. Kathleen's got it. They are soluble. All right. Salt and sugar are soluble in water. And not really.
I make pancakes all the time.
Okay. What did you call water? Should I Google that? Is flour soluble? Yeah. Is flour soluble in water? No. See, it does not dissolve in water. It's the first thing that comes up. It makes a suspension. Yeah. Yeah. Okay. Okay. I was right. All right. Insoluble in water. Did I say Kathleen? I meant Kayleen. Damn. I think that's what my brain fart did. All right. Okay, soluble and insoluble in water, which we've talked about already because we have talked about solubility as a property with the types of solids. Cool. So when we look at our checklist, if you guys remember, we'll just go back to actually I'll go to the last slide. You guys can see it there. So we want to define the term soluble and insoluble. So we got that one, I'm guessing, whether or not it dissolves in the solvent. Why is this not going back now? There we go. All right. So some other things to kind of think about is what we're talking about terminology-wise when we are talking about solubility. So if you had a beaker, the item that is the liquid, most commonly water, is the solute or the solvent? Solvent. All right, so that is the liquid doing the dissolving. Often water. All right, and then what we are mixing inside it is going to be the solute. Is it? Oh, thank you. What's getting dissolved in the solvent? Solute, solvent. All right, so if something is soluble, it will dissolve. If something is insoluble, it will not dissolve. That's how those two terminologies work. Are we okay with that so far? Yes? All right, I'm just going to show you. So it's dissolving in the solution. And then the combination of these two things, when we mix them together and it is dissolved, is known as the solution. So this thing that's created here creates a solution. Cool. Now, it's important terminology to refresh, because when we're talking about precipitation reactions, we are talking about something that is formed that is insoluble. So let's look at those reactions that we had before. Just trying to find one. Those are displacements. There we go. All right. So in this example here, we had lead nitrate and potassium iodide. Both of those ionic solutions are soluble. Now, if I mix them together, I'm now mixing all the ions so that they can interact with each other in this new beaker. And when I do that, I have some new combinations. I have potassium nitrate as one combination. That is still soluble. But I also have lead iodide. Now, lead iodide, we see that is a solid at the end, so that tells me that this product is insoluble, thus forming a precipitate. The precipitate is that solid that is forming out there. Do you want me to draw a picture to show that? Are we okay? Draw a picture? Okay. I'll put this guy down. So, in my beaker, number one, I have a solution of lead ions and nitrate ions, like that. I pour into that beaker. See? I pour in another liquid, and that liquid there is potassium iodide. So it has ions of potassium and ions of iodide. Are we okay with that so far? Yeah. All right. When I mix those two things together, I get one big beaker. And in that beaker, I have lots of different ions floating around. Now, when the lead ion interacts with the iodide ion, it's going to sink to the bottom. And it's going to form a precipitate. And that is insoluble. So it doesn't dissolve in water. The other two components, potassium and nitrate, will stay in solution. So those will still be soluble. So when you guys did this last year, you would have seen solids forming. Do you guys want to see a video just to help reinforce that, or is this ringing a bell from last year? I see lots of head shaking no, so that tells me you're okay. All right. Questions, concerns, comments. PPT, remember? PPT, you would write PPT a lot, precipitate. Mix them together, falls out. Cool. All right, moving on. Can I move this? Okay. I think I can pause the recording now.